Okay, this video is on the distributive property. Again, we're still evaluating expressions and algebraic expressions, and now we actually have to use our distributive property in order to simplify our expressions. So remember that the distributive property, you're literally distributing whatever's on the outside of the parentheses, you're giving it to both things on the inside of the parentheses. The sign inside, you're just going to keep that sign. So it's going to wind up being in this case, with the green example, I'm doing something plus something. In this case over here, I'll make it a red example. We're going, again, A gets distributed to B, and A gets distributed to a negative C. This is going to be a subtraction between the two things. And you'll see what I mean as we do this. So the first one here, again, I like to circle the terms and then circle what I'm distributing to, because it helps you again with the signs, especially on that red example over there. We have an A, and it's getting distributed to the B. Remember that the parentheses tell us that we're multiplying. When we have a number or a letter right outside of the parentheses, like that A, it's telling us that we're multiplying it by what's inside. So that means A times B. So this first part, since I can't actually do it, I'm just going to put it next to each other, AB. That's still, again, two letters next to each other also mean that it's multiplication, A times B. Now remember, we also have to distribute the A to the C. So, and it's a positive C. So again, this A is now being distributed to the positive C here. That means A times C, and it's a plus AC. And again, because I can't actually multiply my two variables together, they just get sitting next to each other, and I'm done. That has been simplified. If I was to simplify anything else with other variables, it would look very similar to this. So it would be the first, like AB plus AC. The next one here, though, again, in our red example, the reason why I like to circle them, the first part's pretty simple. It's still A times B. So that's still going to be AB. But we also, now we have A times a negative C. So a positive A times a negative C makes a negative, and then it's AC. You could just put the sign there and then multiply, but I like to keep the sign with it and take care of the sign that's going to take care of my adding or subtracting sign in my simplified expression. So it's just kind of an easier way to do it. All right, let's do a couple of examples here. I'm going to do all four of these first of all. These are our just our guided examples that we have. And we're going to, again, distribute just like we did. So this is a positive to a positive. That's going to be a positive 4x, 4x. Because, again, I can't actually multiply them, but I can put the letter and the number right next to each other. That does mean it's 4 times x, and I've simplified that part, and I'm done. But I still have to distribute to the 9. So I'm going to take I've got to distribute the 4 to the positive 9. That's going here. And then a positive times a positive is a positive. I took care of my sign. And then 4 times 9 is 36. This is my expression simplified. I've taken care of the parentheses, in other words. Remember, also in order of operations, I have to do parentheses first. Doing distribution takes care of those parentheses and gets them gone for us. All right, now I have 7 times k. Again, positive times a positive is positive 7k. Then I have a positive times a negative on this one. So that's negative 21. 7 times 3 is 21. The next one here, I have a negative to distribute. Again, still another reason why I like to circle my terms. This is a negative 3 going to a positive n right there. That means a negative times a positive is a negative. So it's negative 3n. And then this is a negative going to a negative. Remember that a negative times a negative is a positive, and then 3 times 8 is 24. Again, if I take care of that sign, I don't need to think about it again. I don't say a positive 24 or anything like that. I just take care of the sign altogether, and it's done. All right, number 4, we have a negative 2 going to a positive 5x. Negative times a positive is a negative, so that's negative 10x. And again, a negative times a negative gives us a positive, and 2 times 2 is 4. And that, again, is simplified. In every case here, 1, 2, 3, and 4, we got rid of our parentheses, which was our goal. And we did that by doing distribution. All right, let's try number 2 here. It's very similar to what we just did. We have 5 times W. So again, circle the 5, circle the W. 5 times W is 5W. Then I have the 5 times a negative 4. Positive times a negative is a negative. I took care of the signs, so I don't think about signs anymore. 5 times 4 is 20. And again, that is simplified, and I've gotten rid of my parentheses. The next one, negative 5 times M. So it's a negative times a positive gives me a negative 5M. And then we have a negative times a negative. Negative, so a negative times a negative is a positive. And then 5 times 5 is 25. Again, took care of my parentheses, and we distributed everything we needed to distribute. All right, let's jump all the way down to number 11. Because this is sometimes can be a little tricky for people. And there's really two ways that you can think about this. When I'm looking at the negative sign outside of the parentheses, there's one way I'm going to kind of do like this. I'm going to show us our two ways. Okay. The first way I can think of this is saying negative 1 times k minus 2. Okay, so that negative 1 is going to be distributed to k, and it's going to be distributed to 2. So let's go ahead and do like we just did. So what I'm going to do is circle my integers, or circle what I'm distributing. Negative 1 goes to a positive k. So a negative times a positive is a negative, and it was a negative 1k. Again, remember, I don't need the 1 in front of the k. It's understood it's hiding there. Okay. Then I have a negative 1 times a negative 2. Negative 1 times negative 2. And the negative times the negative is a positive, and that's a positive 2. So this is one way to do it. So I kind of actually did the math and everything. The second way that I can do it is I can actually, and let me erase just a little bit so we can see our original problem. Okay. The second way I can do it is I can just think about that negative sign on the outside is saying that everything on the inside is the opposite of what it is. So this is saying, this sign right here, the opposite. The opposite of whatever's on the inside of my parentheses. So that means the opposite of positive k is negative k, and the opposite of negative 2 is positive 2. You can see I got the exact same answer that I had a second ago. So it's just a personal preference on which way you want to solve it, because it's just how you see it and how you see it best. So whichever way is fine, just make sure you are showing your work. Number 14, let's try that one. This is the same kind of thing. So I'm going to kind of do it the second way I did a second ago. This is the opposite. The negative sign is telling me the opposite of 5k, which is a negative 5k. Or the opposite of, the opposite of positive 4 is negative 4. And let's make sure that that actually worked, right? Let's actually do our math now to make sure it worked. That's going to be a negative 1 times a positive 5. A negative 1 times a positive 5. That's going to give me a negative 5k. And then a negative 1 times a positive 4. A negative times a positive is a negative. And 1 times 4 is 4. So yes, I got the same answer twice, so I'm good. And again, that's also a nice way to check your work, to give it a second way to check it. All right, on this one, I'm going to go ahead and do this fraction for you. Remember, ladies and gentlemen, you can't get away from the fractions, and you have to leave it as a fraction to solve it. So there's two ways I can do this as well. The first way is I can just go ahead and multiply and then simplify at the end. So I'm going to do it that way. I know if I'm taking 4 over 9 times 3 over 8w, what I'm doing there is literally 4 over 9 times 3 over 8. And when I do that math, I'm just, remember, multiplying straight across. 4 times 3, that gives me 12. And 9 times 8 gives me 72. So that gives me 12 over 72w. I'm adding to it now the 4 over 9 times a 10. Well, remember, 10 is over 1. So if I do that math, I have 4 over 9 times 10 over 1. And when I do that, it's going to be 40 over 9. Because 4 times 10 is 40 over 9 times 1 is 9. And now I need to make sure that's really all I need to do, because I have my term with a variable and I have my constant. And I need to just simplify now. So the number that goes in evenly to both 12 and 72 is 12. So that becomes 1 over 6. and that's W there. And then the 40 over 9 actually doesn't reduce. That's going to stay 40 over 9. And so this, sorry I squeezed it in there, that is my answer there. The other thing I can actually do, though, is I can simplify before I multiply. And that makes it a little easier so I don't have to do it at the end like I just did. And then it makes my math a little easier. So I'll do this in red so you can see it. I'm going to take just that first expression right there, the 4 over 9 times the 3 over 8. And I know that 3 and 9 have a common factor of 3. 3 divided by 3 becomes 1. 9 divided by 3 becomes 3. So I can do that. I also can see I have 4 and 8. I can always take one numerator and one denominator. So 4 and 8 have a common factor of 4. 4 divided by 4 is 1, and 8 divided by 4 is 2. So now when I do that multiplication, I wind up with 1 times 1, that gives me 1, and 3 times 2 gives me 6. You'll notice that's what we got right down here. See that we had this originally, but then we got it down to here, 1 over 6. But now I took care of that. And remember, that was W. And now we know it's a positive times a positive again, so I'm going to add. And again, we know this is going to become a fraction. Now this part, again, let's look what we had. We had 4 over 9 times the 10 over 1 still. Now here, there's nothing I can simplify. 4 and 9 do not share a common factor. 9, like here, 9 and 10 do not share a common factor. 1 doesn't really count. So that's it. So this is where that will stay, the 40 over 9. But this first part might make it a little easier there. So this also, again, another way to check your work, because both those answers were the same. All right, the rest of these are for you to practice with. Do make sure you're checking your work as you go. Good luck.